All right, good afternoon everyone. I'm Michael Borthwick, VK3 UBM from Melbourne. I came across to the conference overland, arriving New Year's Eve, an epic 4-day crossing. I'm actually a volunteer at the conference, so I haven't been able to participate this morning in your open radio sessions, but I've been given a few hours off to come in here and show you a video that I made of my participation in a VHF UHF field day about 12 months ago. There was an FT817 floating around. That would be handy if I could perhaps use that as a prop. Any chance of that? Okay, it's left. What I'll do is I'll just bring up, you got one there? So this is the band plan for the electromagnetic spectrum in Australia. Fantastic infographic. Oh, look at this beastie, that's great. Shows how finely granular the allocation of access to spectrum is in Australia, from very low frequency, short wave, all the way up to multiple tens of gigahertz up here, 300 gigahertz. Hope you can make out some of the numbers, if not, doesn't matter. As amateur radio operators, because we're licensed, because we're understood to be able to use the spectrum responsibly and not cause interference to other, often quite critical emergency services users, broadcasting users, we have access to interestingly and usefully wide chunks of spectrum all over the place, from HF, where you can talk to people on the other side of the world with a mere few watts and an FT817 and an antenna thrown over a tree, up into the gigahertz range where equipment is home brewed, you can't buy it off the shelf, you're dealing with surface mount components, you're dealing with exotic printed circuit board materials made of Teflon, very exciting stuff. If you want to play above the 70 centimetre band here, then you're really into home brew. You're making a device called a transverter or a transmit-receive converter, and what that does simply is multiply the input frequency to a much higher output frequency. So when I go and play in a field day with my FT817, which one of the great features about this radio, actually this isn't an 817, this must be an 857. The 817, which is a little bit more compact, has two antenna ports, one on the front and one on the back, and you can arbitrarily assign bands to those ports. So you can get up the top of the hill with your 2 metre antenna, have that connected to the front, make a contact on 2 metres, and then change up to the 70 centimetre band to 432 megahertz and make a contact on the rear. When you want to connect to your transverter, so say work a station on 1.2 gig, the way I was doing it before is I would literally have to disconnect patch cables, plug it in, flick a switch that would trigger the transverter when I hold down the push to talk switch on the microphone. And that works if the station's there and your gear's working, but if they're not there, then you have to undo all that, go back to 2 metres, which is your liaison frequency, and hope that this station you were trying to work has not moved off and worked somebody else who's a bit more organised in frustration. So it occurred to me that I could switch between all this gear, route the RF signals with relays, and then I thought, well, why don't I manage the band shifting and the frequency using the serial port or the TTL port on the FT817. When I discovered there was actually an Arduino library to talk to the FT817, then that led me to develop the project, which you'll see in the video. This is the 2 metre band, 70 centimetre. You can see where the CB radio service is in relation to 2 metre, up into 1.2 gig land. This is the 2.4 gig or 13 centimetre amateur band. This little block here is ISM, or Industrial, Scientific and Medical, so that means enormous industrial microwave ovens potentially. The whole spectrum can be a total train wreck. There's no guarantee in there that anything will work, and because of the sort of ghetto nature of it, that's where they've crammed Wi-Fi, Bluetooth, 2.4 gig audio video senders, spread spectrum radio control, bizarrely. I mean, everything's in there. You know, it's a real free-for-all, and as we all know, as Ham's the noise floor is coming up in that band, because of all those devices, it's becoming increasingly difficult to make contacts. This is 9 centimetres or 3.4 gig. 6 centimetres, 5 gig, and this is where we've got 802.11a and AC and potentially 802.11n if it's in the 5 gig band, so that's all Wi-Fi stuff up there in the ISM section. And finally 10 gig. Now this is a screen grab of VK3 ALB, Lou Blasco's setup for going out and playing in field days. He has a separate FT817 for each band of interest, so that's about 5 grand worth of radios. Each one of those connects to its own transverter. What my system does, because I use just one intermediate frequency radio, one transceiver, I use relays to switch all that around, and because I'm using an Arduino to shift bands and remember what frequency I was on, it makes this sort of backpack operation, which I'm interested in, much more feasible. This is another shot of what Lou calls his tower of power, his stack of FT817s for a field day operation. And this is a wider shot showing he's actually got a caravan with all this gear in it. And I'm not critical of this approach at all. It's one example of what a dedicated VHF, UHF field day operator invests. But I'm more of a casual enthusiast. I love operating radios outdoors, but I have other interests, and I have other interests within ham radio. So what we'll do is try and play my video now, I think. Can you give me a hand with that, Stephen? And hopefully we're going to have audio out of the laptop that will go through the Lecture Theatre PA. And also be streamed live and recorded on hard drive, which is what I spent this morning setting up at 7 a.m. All right, here we are. So this is about 20 minutes. I will probably fast forward over some of the more mundane contacts that I make later on. But thanks for listening, and we'll have a look at the video now.
Oh, it didn't do what we wanted.
Hi there, it's Mike, VK3.
We will do it a different approach.
We've got audio anyway.
Yeah, I was going to drive it. Visibility of things. I didn't have a mouse.
That's going to play from there, Steve. UBM up on the summit of Mount Anarchy in Victoria. I'm using the trig point here as support for my very modest antenna system. I've got horizontally polarised omnidirectional antenna, a Squallow design for 2 metres. This very simple dipole for 70. I've got 2.4 gig, this is just a commercial Wi-Fi antenna of Yagi from Hills in Australia, and lower down is a bicubic quad which is made out of PC board. So one of the issues I've faced going out portable in these contests is I only have one rig, an FT817, which is fine for 2 and 70 because it's got 2 antenna ports, so you can have, for example, your 2 metre antenna connected to the rear antenna port and your 70 centimetre antenna on the front, and it's easy to QSY between those 2 bands. But when you want to move up to 23 centimetres and 13 centimetres, you need to disconnect your antenna and plug in your IF cable to your transverter, and you need to swap over the PTT lines, and remember to do that. And I often forget to do that in the heat of the competition. I get a bit flustered and can miss out on the contact, and it also requires patience from the stations at the other end. And one of the biggest issues is if you're having trouble making a contact on higher bands, then it's hard to drop back to 2 metres to do your liaison, particularly if your IF frequency is on 2 metres, which is where my 23 centimetre transverter is. So what I've put together is a microcontroller that can interface with the rig and with the transverters, switch some RF relays to route the signal either out to the 2 metre and 70 centimetre antenna, or through the transverters to the 23 centimetre or 13 centimetre antenna. It's based on a library for the Arduino, an FT817 library, which includes commands to talk to the rig. So I was up till fairly early this morning putting that together, and to my surprise it actually works. Hopefully I can work some stations on 2.4 and 1.2 and actually demonstrate how it works. So I can change between 2 metres, 70 centimetres, 23 centimetres and 13 centimetres without having to reconnect anything, and that's a huge advantage and means you can move up to those higher bands with confidence. And if you're having trouble making the contact, it's much easier to drop back to 2 metres to your liaison frequency and try and sort out the problem, and it means that the station at the other end is not waiting quite so long wondering what's going on. It's not as good obviously as having multiple rigs, but can't afford to have a rig for each band, and it would also be more weight and more power. So this is, I think, the next best thing, using a microcontroller to try and unify all the gear so you've got push button switching between bands and management of those signals. Now what I'll do is I'll power cycle the controller. It actually needs to set the radio to 2 metre liaison frequency for a start, just to bring the two systems into sync. So if we get around here before the system boots, what we should see is the display change to 144.150, which it's done. And I might unplug my headphones so we can see if there's anybody there. Okay, so there's VK3ER calling CQ on the 2 metre liaison frequency 144.150. Now if we wanted to go up to 70 centimetres, press the 70 centimetre button, and we're on 432.150 where there's actually a contact happening. Or there was. Now if we wanted to go up to 23 centimetres, David's transverter has a IF on 2 metres. It's 145 to 1296 transverter, if you can see that in the grass. So if we press the 23 centimetre button, we'll go up to 435. Sorry, delete all that. Okay, 145.150. And that's also changed over the relays that are in this shortbread tin that switch between the 2 metre antenna and the 23 centimetre transverter. Now if we wanted to go up to 13 centimetres to my transverter, my IF is on 70 centimetres, so we'll go up to 435, and we're on 435.150, and the relay's clicked over, and that's bypassing the 70 centimetre antenna, my modest dipole, and that's now connected to this VYARDI antenna. And as I mentioned, the push-to-talk signal, which is coming out the back of the rig here, is also routed to the correct transverter, so you're not simultaneously keying up both transverters. So hopefully you've been able to see the display. I really can't tell, unfortunately, in this viewfinder in the bright sunlight, but if you haven't been able to see it, I'll fake it up at home. Now I might try and make some contacts and can see this set up in action.
Yeah, VK3UBM, 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 VK3YFL, calling enlisting.
VK3YFL, this is VK3UBM.
Yeah, roger, VK3UBM, VK3YFL, number to you is 59076, 59076, over.
VK3YFL, VK3 Uniform Bravo Mike, thank you for the 59076, my number to you 59029, 59029, over.
QSL 59029, so all good, so give Ross a call, VK3 UBM, VK3 Wildfall.
VK3 YFL, VK3 UBM. Can I just grab the grid square there, please?
QF22 Pop Oliver, QF22 Pop Oliver.
Okay, all received.
So I'm just exchanging grid squares there. That's a Maidenhead locator, so it just says where I am on the surface of the Earth and where the other station is. And in a field day, that's relevant in terms of scoring.
Just stand by, please.
And you also exchange a serial number to prove that you actually made the contact, and then you submit a log to the people running the contest, and they check it to make sure that you're not being naughty.
My number to you, 59030, 59030, received.
Yeah, roger, VK3 UBM, 59030, thank you very much.
Okay, should we give 13 centimetres a bash?
We can, 2403, 170.
Okay, sounds good.
Roger, I'll meet you there.
Alright, here we demonstrate the magic box. Press the 2.4 gig button. And go up to 170. And hopefully there'll be a station there. However, we do have to plug in the 2.4 gig transverter. So then on a power saving drive. So we'll just lean over and do that. And hopefully we'll hear a station calling. And we'll swing the antenna around. VK3 Mike Yankee, VK3 Mike Yankee, do you copy VK3 Uniform Bravo Mike? VK3 Uniform Bravo Mike on 13 centimetres, over.
VK3 UBM, VK3 Mike, how do you copy? Okay.
Yeah, very good signal, over.
Excellent, I'll give you 59074, 59074.
Thank you for the 59074, VK3 Mike Yankee. My number to you, 59031, 59031, over.
Thank you for the 59031, that's excellent, good contact. We're going to be 59074. You can't go any higher than this, man.
Sorry, just go again there, please.
We're going to go any higher.
Face the other way.
Yeah, one of us is drifting off frequency a bit. I'll give you a long over and see if you can net me in there, VK3MY, VK3UBM.
Yeah, I've got you again. Yeah, no, you're drifting up slightly. It might be warming up a bit.
Yeah, look, I only just plugged the transverter in. I'm trying to save battery power. I've only got a very modest battery and a reasonable amount of gear to run over.
See if this works.
Yep, sorry, it was my mistake. I thought we were going to 100, so that was a delay there, over.
Yeah, no problem. Anyway, if you're 59011, so if you'd like to run a number by us.
Yep, you'll be 59036, 59036, over.
Okay, QSL the 3, colour that in, hit the 6, and hit the go. Say QSO. Righto, we're back on track. No problem, over.
Okay, thanks for the contact.
Yeah, terrific signal on 2403. Great. VK3UBM, VK3UHF.
Okay, 7-3s. Alright, back to 2.
your VQJ.
Okay, so what have we got inside the controller? A push button front panel, an Atmega 8-bit microprocessor from Atmel with 8 kilobytes of flash RAM, 2 read relays on the board, 5 volt read relays. The push to talk signal from the mini DIN8 accessory connector on the FT817 comes in on this beige cable here, which is an old Macintosh serial cable. That signal is presented to the 2 relays, and depending on which transverter is selected, will be routed out to the push-to-talk input on the transverter to key it over from receive to transmit mode. These 2 additional read relays over here on the right are just mounted dead bug style on a scrap of PCB, and they handle switching the RF relays. While the surface mount RF relays have 3 volt coils, they require more current than the microprocessor can provide directly, so these read relays take care of switching power to the coils of the RF relays, and we have a 7805 down here to provide the extra current. The microcontroller board has its own 78L05 surface mount regulator underneath on the track side of the single-sided PCB, but that can only provide a maximum of 100 milliamps. This is the Molex KK connector, which goes to the front panel. This is just a standard board that I use for playing around with the AVR microcontroller using the Arduino software environment. So there's nothing very complex here at all. A microprocessor and 4 relays and push buttons for selection of the band.
Field A, CQ Field A, VK5 SR portable caller. CQ Field A, VK3 FASWM, VK3 Fox Alpha Sugar Whiskey Field A.
VK5SR, do you copy VK3 UBM?
Yeah, Roger. I missed the call, but anyway, we did copy you, over.
Yep, VK3 Uniform Bravo Mike. VK3 United Bravo Mexico received.
Yeah, Roger, VK3 Uniform Bravo Mexico. VK5 Sierra Radio, good afternoon. You're not strong, but we are copying you okay. Just the QSB was pretty severe today for some reason or another. Yeah, Roger, Roger. And okay on the low power. Well, we're running a little more power than that, but we're running a bit over 100, so there you go. Probably it makes a lot of difference. But anyway, your batteries will last longer than ours, I'm assure you of that. Over, over.
Thank you. Any questions at all? Yep.
Did you build the transverter yourselves, or
The 1.2 gig transverter I borrowed from David, who edits the VHF UHF section of Amateur Radio magazine, VK38Z, so that's his. The 2.4 gig transverter was built from kit PCBs from VK5 EME, minikits.com.au, which are all beautiful little surface mount. There's a local oscillator, ×4 multiplier chain, a transverter board itself, and a sequencer. So all four boards of those, and they're in quite a compact little Eddystone die-cast aluminium case. The output is only 80 milliwatts on 2.4 gig, and I made contacts up to 100 kilometres during that contest using a Hills Yardie Wi-Fi antenna with 15 dBi of gain. So it works really well.
does the Arduino give you control over which antenna is placed?
It could. I'm not bothering to do that. I'm just presetting the radio through its front panel memory structure to send 2 meters out the front
reach out to Grant Diffie and people who know much more about C and Arduino and compiling libraries and stuff than I do. It wasn't trivial to get the library working. There was some compilation errors and stuff, and he just commented out bits of the library until it compiled. And we loaded it up, and off I went. Yep.
So, are there any more questions from that? All right. Thank you very much.